In this video, we are going to talk about composite function. So let's begin. So in order to talk about the composite function, what I'm going to do, I'm going to consider my function. So this is my operator, and this operator is for function. This operator is for function f. So if we substitute an input value, this is my input value, and I'm going to consider that input value as x. So if I substitute my input value as x, then my output value will be, my output value for x would be fx. And what I'm going to do, I'm going to take that fx as my u. Alright? Now, I have another function right here. I'm going to take that function as function g. So, if my input for this function is fx, which is equal to what? U. So u is equal to fx is my input for function gx, then my output will be, my output for function g, and my input is u equals to fx, will be g of u. Right? So if I simplify this, I can say that if my input is x to a function f, that gives me fx, right? And if I take that output in another function, which is my function g, so this will be my input now right here in this function, then my output for that function will be g of u, which is basically what? G of fx, right? And this whole process of finding the function is known as, we call it composite function. And the reason why we call it composite function, because we are combining two functions to get our final output, right? If I want to write this whole process in terms of mathematical symbol, what will I write? I will write g of f of x is basically g of fx, and that is also g of u, because this part right here, f of x, is basically my what? This is basically my u, right? But we can also find f of g of x, and if we find that, we will write it as f of g of x, and we can consider that g of x as v, so we can write that as f of v. Alright? Now, let's consider an example. So, I'm going to consider an example. So, my example is f of x is given as x plus 3, and g of x is given as x squared plus 1. I want to find f of g. This is the first thing I want to find. And the second thing I want to find is g of f. So let's start with the very first thing. So I'm going to find, first I'm going to find f of g. So I will write f of g of x is basically what? F of g of x, right? And for every gx right here, what I'm going to do, I'm going to put gx from here, which is what? X squared plus 1. So I will write this is equal to f of gx is x squared plus 1. So I will write x squared plus 1. Now this function f will treat x squared plus 1 as x. So for every x for the function of fx, we will replace by x squared plus 1. So we will write this is equal to my fx is x plus 3. So for this x, I will replace by what? X squared plus 1. So I will write x squared plus 1. This is my, this part right here, right? Plus what I have, 3. So I will write 3. Now if I simplify further, I will have x squared plus 1 plus 3 is 4. So my f of gx is basically x squared plus 4. Now let's find the second part, which is g of x. So my second part is g of f of x is basically what? G of fx, right? So I need to see what is my fx from there. So as you can see, my fx is x plus 3. So I'm going to replace my fx as x plus 3. Now, when I consider my function gx, I will replace every x in the function of gx by x plus 3. So my function gx is x squared plus 1. So I will replace each and every x by x plus 3. So I will write g of fx is basically equal to what? X plus 3 in place of x. So I will write x plus 3, and if you see I have a square term right there, so I will write squared plus I have 1 right there. Now as you can see, f of gx is x squared plus 4 and g of fx is x plus 3 whole squared plus 1. So we can easily see that f of g of any function is not equal to g of f of x, right? And this is how we will find the composite function for any given function. So basically, in other words, if I want to say that a composite function is basically combining two given functions to get our final overall function